Okay, hi dear students. So again I am Riyaz Ahmed. So we are part of Brainiacs classes. So let us discuss today's Brainiacs capsule. Okay, so today we are going to discuss the most important questions, or I can say three important questions from the chapter, some basic concepts of organic chemistry. Okay, I know that this chapter, most of them they say it is little bit difficult, but I can surely say this is one of the very easiest chapter. You can go to Brainiacs Classes YouTube channel and go to the playlist. You can find GOC. You can watch the videos. Okay, surely it will help you. Okay, so let's start with our discussion. Okay, so the first question in front of you is the IUPAC name of this particular compound. That is what we need to do. Okay, so let me first draw the structure for you one more time. Okay, so that you will get a sufficient time to understand okay what can be its answer. Okay, so let me draw it for you one more time. Okay, the structure looks like this almost. Yeah. Okay, all of you have got the answer. I hope some students may already have got the answer. Okay, here you can see a COOH is connected. Okay, COOH is connected. Okay, and you can see here on the top you can see a carbonyl group is connected. Okay, what is there? A carbonyl group is connected because it is carbon, and you can see double bond. Okay, and you can see one next to the carbon, you can see there is a CHO, that is nothing but our aldehyde group is being connected here. Okay, so I can write here, let me say O, here H, and here my carbon. Okay, maybe it would be looking a different one, or I would put it like carbonyl group for you to understand it easily. Okay, I will put directly C double bond O H, so that you can easily identify this is nothing but our aldehyde group. Okay, so this is what we need to actually put the name for. Okay, now those who know the naming, you know that first thing, whenever you are doing the naming, what you need to do, you need to first check if it is a cyclic compound. You need to check whether functional group is present. So here carbonyl group is a functional group, and here aldehyde group is present, that is a functional group, and carboxylic acid group is present. And please understand, in the priority table, carboxylic acid group has the higher priority. So I can say this is my principal functional group, PFG, principal functional group. So these two, I mean the carbonyl group and the CHO, here behaves like a substituent. Now, as per the rules, this is the principal functional group. So this is connected to some carbon, and that should be given high priority. So I have given 1 for this one. Now I can go either clockwise like this, or I can go anti-clockwise. But I understood, like if you go in the clockwise direction, you will put here 2, here 3, and here 4 will come into picture. But if you go in the anti-clockwise, you will get 2 here, here 3 here, and 4 here. Now if you put the locus or the number locus, if you put, you will get what actually you can see here. Let me say, okay, here I will show you. Listen, you might be knowing, you will get here the locus as 1, 2, 4. Okay, this is my points. But if you go it in the other way, suppose you are going in the other way, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So I can say this would be 1, 4, 6. How you will get this? If you go in the clockwise direction. How you will get this? If you go in the anti-clockwise direction. Now, by applying the first point of difference rule, you can understand that first numbers are same. So I should take the second number and compare. So here second number, while I am comparing, I understood 2 is a lesser number. So I can say this numbering is correct and this is wrong. So that is how we are numbering it in the what direction? Anti-clockwise direction. Okay. We are numbering it in the anti-clockwise direction. I hope this point is clear for you. Okay, you understood the numbering. Okay, now Now what is the next thing? We need to put the name for this one. Now please understand, whenever COOH is present in a ring, and that too the COOH is present just singularly outside, that means only COOH is present, it is not connected to any other linear chain, so this is present outside as a single carbon. So in that case, we use the suffix as carboxylic acid. We use the suffix as what? Carboxylic acid. Very, very important. Okay. Now let's put how many carbon atoms are there in the ring. We know that 6 carbon atoms are there. So I can say the word root is here hex. Okay. So I can say hex and the substituents are at the 4th and 2nd positions. So I can say like in the 4th position you have an aldehyde group and the 2nd position you have carbonyl group. Now looking at the options, I can say at the 4th position it is formyl, that is what we used to say for CHO, and keto group we say oxo. So alphabetically F is coming. So I can say it is 4 formyl. Then what you can say, 2nd position you have oxo. So 2 oxo. Word root, how many are there? You can say 6 carbon atoms are there, but the parent chain is cyclic in nature, so we use the term cyclo. Then 6 carbon atoms, so we say cyclohexane. Usually we used to say cyclohexanoic acid, but that is wrong, because here carbon atom COOH is present outside the ring and present as a single carbon. So we used to say cyclohexane carboxylic acid. So what is the full name of this compound? I can say 4-formyl 2-oxo cyclohexane carboxylic acid. This would be the correct name of this compound. Okay, so you can see that option is present as option 2. Correct? Option 2 should be the correct answer. Okay, yeah, I put it like this. Okay, now I can give you some more examples to make you understand little more clear. For example, suppose you are getting a question like this. Okay, with this example you will get a clear picture, I am sure. Okay, this is even mentioned in the NCERT textbook. Something like this, COOH. Here also you can see the ring is present here and COOH is present as a single carbon outside. So what would be its name? I can say the ring is present, so I will use the term cyclo. 5 carbon atoms are present in the ring. Okay, there is no substituent, so I don't need to put the numbering. Again, this will be 1. You can number it either clockwise or anti-clockwise. So we can say cyclopentane. Why pentane? 5 carbon atoms are in the ring. Cyclopentane, again we need to mention cyclopentane carboxylic acid. Clear? Now, how I can modify this question actually to make it look like in a different way? Listen. Now, suppose I am modifying this question in like this. Okay, I will use this space itself. 1 minute. Okay, so just I am modifying this question in a way. Listen. So I am rubbing this for your understanding. Okay, I am going to modify this question. Listen. Suppose you can see here I am modifying it in another way. So now you will understand why that is important. Okay, the only modification I am going to do here is I am going to add a CH2 here. CH2COOH. In this case, which would be the parent chain? Listen, here COOH is not present as a singular stuff. Along with that a carbon group, along with that a carbon chain is there. So my parent chain here would be this one. Okay, 1 minute. Yeah, I will choose it like this. Okay, so my parent chain here would be this one. Okay, why? Because we need to take the parent chain that is connected to the functional group. But in the former case, there was only one COOH was present. There is no other carbon atom attached to it. That is the reason I have chosen ring as the parent in the previous case. But here this is my parent chain. I can number it like this, 1, 2. So I can say in the second carbon there is a cyclopentyl is present as a substituent. So I can start with 2 cyclopentyl. In the parent chain you can see listen, okay, 1 minute. Okay, 2-cyclopentyl. Okay, parent chain have 2 carbon atoms, so we say eth, and they are connected through single bond, so ethane, 1 oic acid. You can see I am using oic acid. Why? Because now the COOH, the carbon atom of the COOH is part of the parent chain. If it is not part of the parent chain, we use the term carboxylic acid. This is very important point. You can expect questions like this for NEET exam. Okay, so I hope all the three, I think we discussed 3 questions here itself. This you have understood. Okay, now let's go to the next question. Next one is also very important. The question asked here is, which are metamers? So they have given you 4 options and they are asking which of the following are metamers. So here if you take the first option itself, you can see here first option is CH3, okay, or you can see here CH2 and CH3. This is the one part. The other one is CH3, CH2, O, CH2, CH3. Okay. Now listen. Now to find the metamers, I have a shortcut for you. What you need to do is, what is metamers fundamentally? They say that if you have a polyvalent functional group like this, okay, and across the polyvalent functional group, across means what? On both sides, if you have different arrangements, if you have different alkyl chains attached to it, then we can say they are metamers. So fundamentally what we need to do here is, you number it like this, 1 like this, and this is 2, and you can make this as 3, and this you can mark it as 4. Then what you need to do, you need to compare, always do it like this, then never you will fail actually. Compare 1 and 3. Also compare 1 and 4. These both, while comparing, it should be different. This is one condition. What is the next condition? This should be different. Next condition is take 2. Okay, compare with 3. Okay, and take 2 and compare with 4. While comparing, these should be different. If these are different, then I can say this is fundamentally they are metamers. They will be metamers. This is the simple technique. Okay, or at least, or we can say both of them should not be different, or at least one case is different and other can be same. Even that is also possible. Both should not be different, one is different and other can be same. Like while comparing, you understood both are same. That is also metamers. Okay, or both should be different, that is also metamers. So here I am taking the comparing and doing it. I am taking CH3. Okay, I am doing it in the same way. Listen, I am taking CH3, and I am taking the third part. Third part is my ethyl part, that is CH2, CH3. I can see both are different, so I can put unequal to sign. Okay, take one CH3 again I am taking, and I am going to compare it with the 4. That also I understood. Again that is also ethyl part, so I can say that is different. Okay, now take the 2. Second part is propyl, so I am taking that CH3, CH2, CH2. Okay, I am going to compare it that with the 3, that is ethyl, that is also different. Okay, and again I am taking it. This you don't need to write it like this, you can see and find it out. Again you have the propyl part. Okay, propyl part is present, and compare it with the 4th one, that is ethyl. So I can say they are different. So I can say the first option itself, they are metamers. Okay, so my answer would be option 1 would be the correct answer. You can apply this rule to anything. Okay, so that you will not get your answer wrong. Now if you are seeing the option 2, I can easily say this is an ether. This is an ether, correct, and this is an alcohol. So if they have the same general formula like 4 carbon atoms, here also 4, then they will be functional isomers. Okay, they are not metamers. Now third one, if you see CH3O C2H5 and this one, this you if you just reverse this one, you can say they are identical. They looks the same way. Or if you have a doubt, what you need to do, you just take it and apply the same rule, you will get it. Okay, so for example, for your understanding, I am taking it. Okay, here you can see CH3O C2H5. Okay, here one was C2H5 was present first, then OCH3. If you have a doubt, you put the name. If you put the name, you will get this is methoxyethane. This one is also methoxyethane. Okay, that is how you can easily get it. Or if you have a doubt, you can do it like this, what I have taught you. Okay, this is 1, this is 2. Okay, and this you can put it as 3, and this you can put it as 4. Now you compare 1 with 3. 1 not equal to 3, I understood. 1, if you are comparing with 4, I am getting it as 1 equal to 4. Understood? So here same is coming into picture. Same. Okay. Now 2, you compare it with 3. Here also you are getting it as same. 2 is equal to 3. So here also same is coming into picture. And 2, if you are comparing, that is not equal to 2, not equal to 4. But please listen, in both case if same are coming, in both case or in either, in both case if same are coming. So here you can see same is coming, here also same is coming. They are not metamers. They are not metamers, or they will be identical. But if you have different in both, in the first case both are different and next case both are same or any one of them same, then also they will be metamers. Okay. I hope this concept would be clear for you. If you have any doubt, feel free to ask in the comment box. Okay, so let's go to the last question for the day. Okay, I hope you could see it. Okay, yeah. Now the question here is the most stable carbocation from this one is. Okay, so let's draw and understand the concept, then you will get a clear picture. Okay, so you have compound like, okay, let me say a benzene ring is present. Anyway, I need to draw 4 benzene ring. Okay, so you have something like this. Yep. Okay, so yeah, so you can see here a benzene I am drawing. Okay, okay, now we can recreate this benzene in different ways using this tool. Okay, yeah, we will copy this and we will paste it here also. Okay, here also we will paste. We need one more. Okay, and here also we can, one more we can paste. Okay, fine. Okay, that's it. Now let's draw. Now in the first one you can see CH2 plus and chlorine is connected. So here if you see, you have CH2 plus, so that means it is a carbocation. Okay, and what is connected here? Chlorine is connected. Okay, now if you see in detail inside, if I am removing this one and putting this one, okay, like this one, so it's very easy for you to understand that. Now if you see here, you can see positive charge, okay, single bond, then you have double bond, then single bond, again double bond, single bond, again double bond. You can easily say there is a conjugation or resonance is present, and that resonance is stabilizing this carbocation. There is no doubt in that. But this is common for everything, because in everything you can see CH2 plus is present like this. So everyone is fundamentally stabilized by resonance. Then how they are differing? That is the most important question. They are differing in the way in which some group is attached at the para position. So in the second one, you can see there is a nitro group is being connected here. What is connected here? A nitro group. Okay, and in the third one, you can see the methoxy group is being connected here. Methoxy group. And in the last one, nothing is present. Now we need to understand the relevance of these things. What this chlorine will do to this one? I can say the chlorine here has minus I effect, and also it has plus some effect. Minus I effect means it will pull the electrons towards this direction. towards this direction as part of its electronegativity. Plus sum effect means chlorine has 3 lone pairs. We know chlorine has 3 lone pairs. It will donate the lone pair to here, to the ring, and it will enter into resonance. So it will, donating the lone pair means the plus charge will decrease. We know that here the question is which one is more stable. So please understand a very important point related to stability. Stability is inversely proportional to charge density or charge. Very, very important. Now I can say chlorine has always, it's a special case. Halogens always have minus I effect more dominant than plus sum effect. So what will happen? The electrons will flow in this direction. Through the sigma bond, the electrons will flow like this. Electrons are moving in the downward direction. So what will happen when electrons flow in this direction? The positive charge density over here increases. The positive charge density in the carbon increases because electrons in this direction, positive increases here. So charge increases here. So charge is what happening to the charge? It increases. So charge density increases means stability here would decrease. So I can say this is less stable. The first one, the first structure we are seeing here is less stable. Now next one you have, what group is connected, sir? NO2 group. It has minus I effect, also minus M effect. So what minus I effect will do? It will pull the electron in this direction, and minus M effect will do what? It will also pull the electron from the pi bond. Pi bond will move towards the NO2 group. Here you can see, here also I can remove this and put the pi bond for your understanding. Okay, so the pi bond will move towards NO2, or it will go to NO2 to enter into resonance. So that means as a whole, the electron density is moving towards the downward direction. Electron is moving in the downward direction. That means the positive charge over here is increasing very fast. So I can say the charge density increases very fast, the stability decreases very fast. So I can say this is the least stable structure. And in the third one if you see, methoxy group, and this have minus I effect and plus M effect. But please remember, usually when inductive and mesomeric effect is there, always mesomeric effect dominates over inductive effect, except in the case of halogens. Very, very important. Okay, so here plus sum effect is more than minus I effect. So I can say even though minus I effect is pulling the electron in the downward direction, but oxygen has 2 lone pairs present, so that will donate the electron in this direction. And what will happen when electrons move in this direction at a higher rate? I can say the plus charge present here decreases. Plus charge present here decreases. So charge density decreases, stability increases. So I can say this is a stable structure. So this one doesn't have anything. So I can say this is my third structure. And this is my fourth one. This is my second one. So if you arrange it in a stable way, what is the most stable one? I can say third one is the most stable one. Then I can say the fourth one because it does not have anyone to pull the electron. And then comes the first one, then comes the first one, and then comes the last one, that is 2. So this is my stability order. This is my stability order. Okay. So I hope you understood the concept. So the question here is most stable carbocation. Most stable means less charge coming into picture, and my answer is option 3 would be my correct answer. Okay, I hope you understood. Okay, if any students have more doubts, you can subscribe our YouTube channel. You can go to playlist and watch the videos. Complete description is there, or a full description of entire chapters you can see there. And still, if you feel like more offline classes is required, you can contact Brainiacs Classes, which is one of the best NEET institute available in Coimbatore. Okay, thank you.